Hi, my name is Wilmar Sánchez. I'm studying electronic engineering in the UNAD, Universidad Nacional Abierta a Distancia. This is my document, and now I explain the development of tax 2, electromagnetic waves in bounded open media. Okay, my name, my group, my code, and this is for the electromagnetic and waves theory course. Okay, the first parts are questions. First, what are the modes of propagation of electromagnetic waves? The classification is related in transversal mode and have four ways. The first is transversal electric mode, when the component of electric field in the direction of propagation is zero. The transversal magnetic mode, when the component of magnetic field in the direction of propagation is zero. The transversal electromagnetic mode, when the components of electric and magnetic fields in the direction of propagation are zero. And hybrid mode, when the component of electric and magnetic fields in the direction of propagation are different of zero. Second, what is the phenomenon of total reflection of an electromagnetic wave? Okay, the reflection is the phenomenon when a wave finds a new media and part of the energy of the wave is rebound or is reflected, and is a total reflection when don't have um, refraction. Oh, this is the condition to have a total reflection. 3. What is the phenomenon of total refraction and of an electromagnetic wave? Okay, the refraction is the energy that passes to the new media, and the total refraction uh, exists when the reflection angle and the refraction angle form an angle equal to 90 grades. For what is the purpose of Snell's law in the study of the propagation waves? Okay, the Snell's law is this enunciate and relationed the media and the grade of incidence and refraction. And it's important because have used in the electronic, like the optical fibers. Okay, application exercise. First, an electromagnetic wave of frequency GG and power 120 incident from the air perpendicular to an infinite wall with an intrinsic impedance. Calculate the reflected power and the transmitted power to the wall. So this is the graphic. We have a wave that found a new media, that is the wall. Part of the energy is refracting or passed to the wall, and part of the energy is reflecting or rebound to the edge again. Okay, this is the values of the frequency. 6 because it's the number of my group, the potence and the medias give for the exercise, and the power reflected and refracted, that is we must find. Okay, the reflectance, the first is find two reflectance. This is the formula. we replace it and find that the reflectance index coefficient is equal to 0.95%. It's so small, smaller, minor than 1%. Now I found the transmittance. The transmittance coefficient is equal to 1 minus the reflectance coefficient. Replace it and find that is equal to 99.05%. To find the reflected power, I multiplicate the power for the reflectant coefficient and the total and the value of reflected power is 1.14 milliwatts over meter squares. And to find the transmitted power, I multiply the total power for the transmitted coefficient and the value is 118.86 milliwatts over meter squared. This is the operations, and the interpretation is that the energy reflected is so small, only one of 120, and the energy that passes, that is the refraction, is almost the totality of energy, 188 180 86 of 120. Second, an electromagnetic wave of frequency GG power 120 coming from a wave generator located 12 centimeters from the wall, which impinged from the air. The N sub 1 is equal to 120 p ohms perpendicularly on a wall with an intrinsic impedance N sub 2 and 20 centimeters thick. The wall is made of a non-magnetic and not dissipate material. On the other side of the wall is a receiver located 20 centimeters away. Okay, this is the graphic of situation, the generator, the waves, the wall, a new air, and receiver. Calculate the coefficient of reflection and transmission seen by the generator. Okay, the first part, bueno, this is the dates that have from the enunciate. Frequency, 6 for the group. Power, distance, the medias, coefficient, refraction, and okay, how is a non-dissipate material? I use the next formula to find epsilon sub r, that is 1.48, and with epsilon I find the phase constant that is equal to beta, and the value founded was 0.15. Okay, with this value I can find the input impedance with this formula. We have the medias, coefficient refraction, the beta value, and the distance. Replace, and we find that the input impedance is equal to this complex number. To find the reflection coefficient, use this formula new again, and this complex number obtained, I elevate to squad and have that the coefficient the reflection coefficient is equal to 0.95%. The transmission coefficient is equal to 1 minus the reflection coefficient, and is equal to 99.05%. Okay, be determined in percent and milliwatts over meter squared the power total that is transmitted to the receiver. Okay, again, first we find the reflection coefficient in to the x equal with this formula. Replace it, development, and find that the coefficient reflection is equal to 0.95, and with this value I find the transmission or refracting coefficient 1 minus reflecting coefficient, replace, and found that the transmission coefficient is equal to 99.05% again. Multiply these two transmission coefficient and find that the total energy perceived for the receiver is equal to 98.1% of the initial power. And the value equivalent of this power is 118.73. According to the concept explored, explain the value obtained. Okay, the coefficient indicate that a little part of the energy is reflected. Almost all the energy, 170.73 of 120, is received for the receiver. 3. An electromagnetic wave propagates through several media. This is the graphic, and use the refraction index and the angles to calculate the distance. That is the question. Okay, the first is we have angle of 44.9. Calculate the incidence angle. Restate the 19 grades. And with the Snell's law, find the angle of refraction. This new angle calculate the second incident angle, and use again the Snell law to find the coefficient refraction of the third media. With this value, find that the third media is diamond. And next we find the Snell law again to find the angle of fourth media. For the distance, we plus the 3 distance, use the tangent, and we have that the total distance is equal to 101.28.89.